making kids love maths. Hello, in this video we'll be looking into direct variation. Direct variation is a form of variation in which one quantity varies directly. Okay, that is, as one quantity increases, the other quantity also increases. Okay, if the value of a quantity decreases, the value of the other quantity as well decreases. Okay, that is direct variation. Okay, now how do we represent direct variation? We'll be looking into that here and how to use to solve problems. Okay, all right, now let's use this question before us to address that. Now it goes thus: the length L of a rod varies directly as the square of its radius. Okay, the length L. So if you have to represent that, the length L, this is it, the length L varies. This is the symbol of proportionality. Okay, varies directly. Introduce that as what? So it varies directly as the square. Now, as the square of its radius. So this is the square of radius, square of its radius. Now we have, when we say it is direct variation, it varies directly, the other quantity is going to be on the same plane. L is a numerator. If I were to say L, we could say as L over 1. And R squared is same as R squared over 1. So you see they are on the same plane. Okay, they are both numerators. Okay, but if it were to be inverse variation, okay, it's going to be L varies inversely. It's going to be 1 over R squared. Okay, this case is inverse variation. Okay, one is a numerator, one is up and the other is down. That is inverse variation. Okay, all right, so having known that, how to represent direct variation. In direct variation, you just know that they have to be on the same plane. The next thing is to introduce a constant. This is a constant, K. You introduce a constant. So when you introduce a constant, you replace the sign of proportionality. You replace it with equality sign. Okay, you replace this sign. Okay, you replace this with the equality sign, equal to. Okay, so it becomes L is equal to KR squared. Okay, now the next thing is to find the value of K. You find the value of K using this statement here, or this clause. Okay, if the length is 4 meters when the radius is 0.2 meters, it means that when the radius, or when the length is 4 meters, the radius is 0.2 meters. Okay, so that very clause is what we have represented here. When the length is 4 meters, this is the 4, the radius is 0.2, this is 0.2. Okay, we get it. So instead of writing R, we have replaced our R with 0.2. Okay, and the statement is L is equal to KR squared. Okay, so L, which is 4, is equal to K R squared, that is 0.2 squared. You get it? All right, now when you do that, 0.2 squared will give you 0.04. Okay, it will give you 0.04. Okay, now you make your K the subject of the formula. Okay, when you do that, so here 4 over 0.04 is equal to k. We have made k the subject of the formula. Okay, now this 0.04, you could make it, if you don't want to use a calculator, okay, you could convert that 0.04 to a whole number by multiplying by 100. When you do that, it becomes 4. Now, whatever you do to the denominator, you do to the numerator. Okay, now you have to multiply 4 as well by 100. Okay, remember we multiply 0.04 by 100. You also multiply 4 by 100 to give you 400. Okay, now we divide 400 over 4 gives us 100. Okay, so 100 is k. Get it? Now that we have known the value of k, we now go back to the equation. This equation which says which says L is equal to kr squared. So this is it now. We have known the value of k. So the value of k is 100. Okay, we now say L is equal to 100 r squared. You get it? So that is the equation. Okay, now the next thing is to answer the question which says find the radius of the rod when the length is 8 meters. Yes, when the length is 8 meters. Now we now substitute when L is 8. This is the 8. Okay. So our K is what? 100. Our R, that is what we are looking for. That's it. Now what follows is just take care of the division. Okay, you divide. Here you make R the subject of the formula. Okay, after doing that you divide. Okay, you divide. This is square here, you bring square, you remove the square, this becomes square root. Okay, you take care of that and arrive at this 0.28. Okay, so that's the value of R. So it means that the radius is 0.28 meters. Okay, so that's it. All right, so subsequent video will take care of inverse variation. Okay, all right, until then, bye.